All right, welcome. Today, we're going to pull back the curtain on one of the most mind-bending technologies out there, large language models. You've seen them, right? They're writing poetry, spitting out code, answering ridiculously complex questions. But how in the world do they actually work?
I mean, it really does feel like magic. You have a machine that can chat, create, and even seem to reason. It's easy to think we've finally built a true artificial intelligence. But the secret behind it all? It's much, much simpler, and honestly, a whole lot weirder than you probably imagine.
Yeah, that's it. That's the big secret. At its absolute core, this incredibly powerful, world-changing technology is built on one of the most basic games you can think of, just guessing what comes next. Okay, so let's really get into this. This guessing game idea isn't just a cute analogy, it is, quite literally, the fundamental way these things operate. Everything an LLM can do, all of its amazing abilities, springs from this one single function. So what even is a large language model? Well, it's a giant neural network, sure, but the part you need to remember is its job description. It is a next word predictor. That's it. It looks at a string of words and then calculates the odds for every single word it knows of being the very next one in the sequence. That is its entire purpose in life.
Now this is where it gets really wild. How does a task that simple, just guessing the next word, over and over, lead to something that looks so much like real intelligence?
The big unlock, the key insight that makes everything possible, is this. You can cleverly reframe almost any language problem you can think of as a simple next word prediction task. Let me show you what I mean.
Okay, let's take something like sentiment analysis. You don't ask the model, hey, is this sentence positive or negative? No. Instead, you just turn it into a sentence for the model to complete. Something like, the sentiment of the sentence, I like Jackie Chan, is...
And then you just let the model do its thing. What's the most likely word to complete that sentence? Well, based on all the text it's read from the internet, the word positive is going to have a way higher probability than negative. And boom, just like that, you've done sentiment analysis.
Let's do another one. Answering a question. It's the exact same trick. You format the question in a way the model has seen a million times before, like this classic Q&A format.
And the model just predicts the most probable next word. In this case, that word is Charles. And if you feed that back in, what do you think it predicts next? Darwin. It doesn't know the answer. It's just completing a pattern that it's seen countless times in its training data.
And this example just perfectly shows how powerful this simple trick can be. You can feed the model a whole long article and then just tack on the internet slang TLDR, which, stands for too long didn't read.
The model has seen TLDR billions of times, and it knows that what comes next is almost always a short, punchy summary. So it predicts the sequence of words that best fits that pattern. It's not reading for comprehension, it's pattern matching on a truly massive scale.
Which, of course, leads to the big question, how in the world does a model get so good at guessing? Well, it all comes down to how it's trained.
The method is called self-supervised training, and it's actually pretty straightforward. You just take a horrifyingly large amount of text, like a huge chunk of the internet, and you show it to the model. At every single word, you stop and ask the model, okay, guess what's next? The text itself has the right answer, so the model can instantly see how wrong its guess was, tweak its internal wiring a little bit, and try again. Now, just do that trillions of times.
And where does all this text come from? Basically everywhere. We're talking colossal datasets like Common Crawl, which is literally snapshots of billions of web pages. We're talking curated collections like The Pile, which mixes in books and scientific papers. And yep, all of Wikipedia, tons of news sites, even patent documents. It learns the patterns from all of it.
Okay, so the model is an incredible guesser, but think about it. If it always picked the single most likely, most predictable word, its writing would be super boring. So we need a way to control the conversation, to inject a little creativity. This leads to a really important trade-off. On one hand, you can tell the model to stick to the safest, highest probability words. That gives you accuracy, but it can be kind of dull. On the other hand, you can tell it to consider some of the less common middle probability words. That gives you creativity and diversity, but you risk it saying something that doesn't make a lot of sense.
And the main tool we use to dial this in is called temperature. Honestly, the best way to think about it is like a thermostat for creativity.
If you turn the temperature way down, the model plays it safe. It's very predictable. But if you crank that temperature up, it starts taking more chances, picking more surprising words, and the output gets a lot more creative and sometimes a lot weirder.
But, and this is a big but, getting this incredible ability to generate human-like text doesn't come for free. To get this good, you need a scale that is just hard to wrap your head around, and that scale comes with a very real price.
Just look at this number for a second. 175 billion. That's how many parameters are in the GPT-3 model. You can think of a parameter as a tiny little knob that a model adjusts during training to get better and better at its predictions. Having this many knobs is what lets it capture all the subtle, complex patterns in human language.
And with that kind of scale, you get some very real challenges that we are just now starting to figure out how to handle. Things like hallucination, where the model just confidently makes stuff up. There are huge questions around copyright, since it's trained on protected material. It can sometimes reveal private information it learned from the web. And of course, there's the massive potential for generating toxic content and widespread misinformation.
But really, when you boil it all down, it comes back to this one central idea. The power of these models isn't some secret magical algorithm. It's the simple fact that our collective written text, every book, every website, every article, contains an absolutely staggering amount of knowledge and patterns, just sitting there waiting for a powerful enough system to learn from it.
So we've built this incredible engine, an engine that learns from nearly everything humanity has ever written down, all for the simple goal of getting better at guessing what we're going to say next. As that engine gets more and more powerful, the real question we have to face is, what should we be asking it to do?